Algebra is an area of mathematics that involves solving for the unknown, and the unknown is represented by letters or a combination of numbers and letters. While advanced algebra is used in many fields such as medicine, accounting, economics, or engineering, basic elementary algebra can also be used for everyday problem solving. In this lesson, we will be looking at defining, explaining, and applying key terms that are associated with algebra, including term, coefficient, variable, degree of terms, and degree of a polynomial. So as I mentioned, algebra is used to solve for a value or a quantity that is unknown. And in order to represent this unknown quantity, we use something called a variable. A variable is a letter used to represent a value that can vary or change. If you put together a series of numbers and letters, you can create what's called an algebraic expression, which is a mathematical phrase made up of numbers and variables, which are connected by addition or subtraction operations. So in the next few examples, we're going to take a look at how to put together algebraic expressions and how those differ from algebraic equations. This is Sally. Sally is entered in a muffin eating contest and can eat 2 muffins per minute. So in our first example, we are asked to write an algebraic expression that shows us the amount of muffins that Sally can eat in t minutes. So t is a variable because it can change. We don't know how long the eating contest lasts. We don't know how many minutes will go by. And so that is something that is unknown. And because it's unknown, it needs to be represented with a letter. So all we know about Sally is that she can only eat 2 muffins every minute. So we can write that as 2t. And when we see a 2 and a t side by side like this, that actually is the same thing as saying 2 multiplied by t. So how does an algebraic expression differ from an algebraic equation? Well, an algebraic equation is an algebraic expression, but it is set equal to another variable, a known value or number, or another algebraic expression. So to make that a little bit simpler, the main difference between an expression and equation is that an equation will have an equal sign. An algebraic expression will just be a number and a letter or both, but an algebraic equation will not only have an algebraic expression, so numbers and letters, but it will also have an equal sign. In example number 2, we are asked to write an algebraic equation that shows the amount of muffins that Sally eats during the contest. But this time, they also want you to use a capital letter A to represent the amount of muffins that Sally eats, and we're still using a lowercase letter t to represent the amount of time. So if we were to put all of that together, our equation would look like this. A equals 2t. So if we had to translate this or explain this, we would say that the amount of muffins that Sally can eat is equal to 2 muffins per minute, or 2 muffins every minute. We don't know how many minutes or how long this contest goes for. And because we don't know that, we also don't know the total amount of muffins that Sally will eat by the end of the contest. So the main point of algebra is to solve for an unknown. And an unknown is a letter or variable used to represent a specific value that is unknown. So in our situation here, what is unknown to us is t, or the amount of time or the length of time for this muffin eating contest. So in our next example, we are asked, what is the actual value of t in your algebraic equation, a equals 2 times t, when a is equal to 20? So this time they're telling you that if Sally can eat a total of 20 muffins, how much time will have gone by for this contest? And remember, she can eat 2 muffins every minute. So we have our equation, a equals 2t, but they are telling us that instead of the letter a, you can go ahead and put in a value of 20. So really when we're looking at this, what this is telling us is 2 multiplied by some unknown number, that has to give us an answer of 20. And so this is pretty simple. It's math that you can maybe do in your head. We know that 2 multiplied by 10 is going to be able to equal to 20. So that means that t has to be equal to 10. 2 times 10 is 20. So if t is equal to 10, that means that in 10 minutes, Sally is able to eat a total of 20 muffins. So basically in algebra, all of the different parts or pieces that are put together to make an algebraic equation, they are called terms. So a term is an expression that is formed by the product or multiplication of a number and or variables. And so a term will consist of 2 separate parts, something that we call a coefficient and what we call a variable. So here in this boxed example, I have a term that is 4x squared. So a coefficient is the number that is found in front of a variable or in front of a letter. So in my term 4x squared, my coefficient would be the number 4. A variable is what consists of 1 or more letters, and it might even be letters and their exponents if there are exponents present. So in our term 4x squared, the variable portion or the variable piece would be the x squared. You have to include the squared because the squared is directly attached to the letter. So in our next example, we are given a bunch of different terms and we are asked to identify their coefficient and their variable, or variables if there's more than one. So our first term is a 6x. So the coefficient would be 6. That is the number that is in front of the letter. And the variable would be x. That is the letter that was chosen to be used in this term. In our next example, we have a term of negative t squared. So what would our coefficient be? If we take a look at our term, it doesn't seem like there is a number in front of the t. But remember our rule in mathematics. Just because you don't see a number doesn't mean that there isn't a number there. And typically when you don't see a number, that actually means that there is a 1 in the front. So the coefficient for this term would actually be negative 1. The variable would be the letter, and because there is an exponent attached to the letter, you need to include that as well. So the variable would be t squared. Our next term is 5. So it looks a little bit different because this time it's just a number. There are no letters attached to it. And that's okay. An algebraic term doesn't always have to have letters. I know we associate algebra with having missing unknown letters, but you don't have to have letters all the time. So in this term, there is only a coefficient of 5. There are no variables. So I'm just going to write none. In our last term, 2wh cubed, the coefficient would be 2. So that's the number that's at the front. And this time, our term has multiple letters, and that's okay. A term can have as many letters as you want. The reason why there would be more than one letter is because there is more than one unknown. There's more than one thing that you're trying to solve for. So if you are identifying the variables, you need to include all of the letters that you see. So our variables for this term would be w, h cubed. They're attached together, so you're going to keep them attached together when you identify them. So now that we know what a term is, what happens if we put a bunch of terms together? If we were to do that, we would get what's called a polynomial. A polynomial is an algebraic expression that consists of one or more terms that we put together, and they are connected by addition or subtraction operators, or addition and subtraction signs. And a polynomial can be classified by the number of terms that it has. So in our next example, we are asked to classify the following polynomials. So I'm going to take you through how to identify how many terms or how many parts there are to a polynomial. And then based on the number of terms or parts, we can give it a name or a classification. So our first polynomial here is 3h. So the 3 and the h together is one term. And so the name that we give something that's just one term is called a monomial. So the way that you can think about this is the prefix mono in Latin means one. Our next polynomial is 6t cubed plus 3t. So this time you have two terms. So how do I know that I have two terms? Well, I've got one term here, and it is being separated from another term by a plus sign. So the 6t cubed is its own term, and the 3t is another term. So we've got two terms. So if you have a polynomial with two terms, we call this a binomial. And in Latin, the prefix bi means two. In our next example, we have negative 3d squared plus 2e to the power of 4 plus 32. So how many terms do we have here separated by addition signs? Well, we've got 1, 2, 3. So this time we have 3 terms, and the name or the classification for 3 terms is trinomial. All right, and the Latin prefix tri represents 3. So you can also see that being used in the word triangle. The triangle has 3 sides. Or you could think of a tricycle, which is a small bike that only has 3 wheels. So tri means 3. Trinomial has 3 terms. And in our last example, we've got a lot going on here. We've got 13x to the 6 plus 75x to the 4 plus 3x squared. Take away x plus 22. So this time, how many terms do we have? We've got 1, 2, 3, 4, 5. So we've got 5 terms in total. So how would we classify this? Well, the rule of thumb is once you go past 3 terms, so if you've got 4 terms, 5 terms, 7 terms, 10 terms, 20 terms, doesn't matter how many, but once you go above 3 terms, we simply just call the classification or the name a polynomial. And the Latin prefix poly simply just means many. So you have many terms. Another way that we could classify a term is by its degree. The degree of a term is the sum of all of the exponents on all of the variables in that term. So in case you've forgotten, the word sum means you need to add. So you are going to add together the exponents that you see on all of the variables in the term. In this example, we are going to look at a bunch of different terms. We are going to take the sum of the exponents, and then based on the value that we get, we are going to classify each term by degree. So our first term is a 3h. So when we are looking for the degree, we are just looking for what is the value of the exponent attached to the letter. So when I look at my letter h, I don't see an exponent hovering or hanging at the top, but I do know in math that if I don't see an exponent, that really means that there is an exponent of 1. Now, that is the only letter that we have in the term. We have the letter h. There's nothing else with it. So there's really nothing I can add together in terms of adding exponents. So the sum is just going to be 1. And so if we were to name this by degree, we would just say this is a first degree or a first degree term. Okay, let's compare that to the next one. So in our next example, our term is negative 4k to the power of 3, or k cubed. So again, we want to look at the exponent that we see when we see the exponent 3. So I'm going to put that in my box here. I don't have anything to add with it, so all I can write is 3. So this would be a third degree term. The next term is a little bit different, and it's different because we have multiple letters and a bunch of different exponents. So before we begin, let's just take a look at our variables, or the letters, and the exponents that are attached to them. So the first variable we see is actually a letter A, and again, it doesn't look like there is an exponent attached to the A, but remember that if you don't see an exponent, that really means that there is a letter 1, or a number 1, sorry. Okay, then we've also got a variable D, which has an exponent value of 2, and a variable E, which has an exponent value of 6. So this time we have multiple different exponents in our term. So this is an actual question where you do have to find the sum, or the addition, of all of the exponents. So we just need to add them together. So we've got 1 plus 2 plus 6, and that's going to give you a total of 9. So in terms of the degree, this would be a 9th degree. And our last term is negative 4. So in terms of the exponents, normally we are looking at the exponents that are attached to letters, but there are no letters in this particular term. But that's okay. Remember that if you don't see an exponent, even if there are no letters, there is still an exponent value of 1. So for the sum of exponents, all we can say is that we've got a 1. And so again, this would be first degree. And just as another reminder, if you have a variable or letter that appears to have no exponent attached to it, it actually has an exponent of 1. And same thing with a constant, or just a plain number that has no letters attached to it. Even that plain number will have a degree, or an exponent, of 1. Our last type of classification is called the degree of a polynomial. So the degree of a polynomial is determined by the highest degree term in the expression. So the highest degree term means you are looking for the highest value exponent in the entire expression. So in example number 7, we are given a bunch of different polynomials, and we are asked to find the degree of the polynomial. And then once we do that, we are going to classify it, or give it a name. So our first polynomial is 3c cubed plus c plus 7. So we're going to take a look at the letters, and we're going to take a look at the exponents that are attached to them. So I've got a c with an exponent of 3, and then I have just a plain c. But remember, when you see just a c, doesn't seem like there's an exponent, there actually is an exponent of 1. Okay, so between the exponent 3 and 1, what is the highest value? Well, 3 is higher than 1. So my highest degree term is going to be 3. Okay, so in my classification box, I can say that this is a third degree, but we have to name this not only by the degree, but also by the polynomial. And remember, to name a polynomial, you need to look at how many terms there are in the polynomial. And based on the number of terms, it gets a specific name. So if I go back to my question, I have 1, 2, 3 terms. Well, the name for 3 terms is trinomial. So 3c cubed plus c plus 7 is actually classified as a third degree trinomial. Third degree, because the highest exponent value that we see is 3. Trinomial, because there are 3 terms being added together. All right, in our next one, we've got 13x to the power of 6 plus 0.75x to the power of 4 plus 3x to the power of 7 plus x plus 22. All right, so we're going to scan through all the different exponents that we see. Remember that on this letter x here, we've got a 1 as the exponent. So look at all the numbers, 6, 4, 7, and 1. What would be the highest? So the highest exponent that I see here is 7. So this is going to be 7th degree. Now, how many terms do we have? We've got 1, 2, 3, 4, 5. We've got 5 different terms being added together. So remember from our list of names, once we go above 3 terms, doesn't matter if we've got 5 terms or 10 terms, we still just call it a polynomial. So this particular example would be classified as a 7th degree polynomial. All right, our last example is a little bit different, and it's kind of a challenge question. So the difference between this example and the ones that we just looked at, we have multiple letters attached together. So it's not just one letter at a time. We have the letter S and the letter T attached or stuck together. So we've got 3st cubed plus 3s squared t to the power of 8. So we've got lots of different exponents here. Again, on this first s, we don't see an exponent, but there is a 1 here. So because you have 2 letters attached together, you can't just pick out the highest one that you see, like we did in the other 2 questions. Because they are attached together, you need to kind of consider them as a packaged deal. So you're going to treat this as one package, and you're going to treat this one as one package. So what do I mean by that? You actually need to add the exponents together first. Once you add them together, then you can pick out which number is the highest or which total is the highest. So for the first term, the exponents that I see are 1 and 3. So if I add them together, 1 plus 3 would give me 4. In my second term, I have exponent values of 2 and 8. So if I add those ones together, 2 plus 8 is 10. So now, what would be the highest degree? Would it be 4 or would it be 10? Well, obviously 10 is the bigger number. So our degree is going to be a 10th degree. Now, how would we name this? Well, we have 1 term and 2 terms. So this is a 2-termed polynomial, and the proper name for something with 2 terms is a binomial. So this is a 10th degree binomial. In our final example, we're actually going to take a look at how we can use algebra to solve somewhat of an everyday type of problem, or a problem, let's say, that involves money. So Cheryl works as a part-time ski instructor. She earns $125 for the season, plus $20 for each children's lesson, and $30 for each adult lesson she teaches. So the first thing we always have to do when we're solving a problem that involves algebra is we have to set up what we call let statements. And the reason why we have to set up these specific types of statements is because you get to pick the letters that you want to use in your algebraic equation. Sometimes questions will give you particular letters that they want you to use, but for the most part, you are able to choose your own letters. However, you need to tell people what those letters represent. So it's almost like making yourself a little legend, okay? Especially for me as a teacher, you need to tell me what letters you're choosing and what they represent. All right, so what do we know about Cheryl? Well, she earns $125 for the season. So what does that mean? It means that if she shows up to work, even if she doesn't teach anybody for the season, she gets no clients, she still gets $125 just for coming in to work. However, for every kid or child that she teaches, she earns $20, and for every adult that she teaches, she earns $30. What we don't know is how many children did she teach? How many adults did she teach? So the two unknowns are the number of children's lessons and the number of adult lessons. So I've gone ahead and picked out some letters. I've said or stated, let C, lowercase c, represent the number of children's lessons that Cheryl is going to teach. Let A represent the number of adult lessons she's going to teach. And what I also don't know is her total earnings for the ski season. So I picked a capital E to represent her total earnings. So how much money she's going to make at the end of the season. So now that we've defined or picked our variables, we can put them together with the information that was given to us in the question, and we are going to write an algebraic equation that describes Cheryl's total earnings for the season. So I know that I picked a capital E to represent her total earnings. And then I'm going to put an equal sign, and let's put together what we know about Cheryl. So Cheryl gets $20 for every child's lesson, plus $30 for every adult lesson, plus, remember, don't forget, she gets $125 just for showing up to work for the entire season. So if we put all of that together, that's going to give us our algebraic equation. So her earnings are equal to $20 for every child, plus $30 for every adult that she teaches, plus that flat rate of $125 for the entire season. And now let's actually try to solve this. So one winter, Cheryl gave 8 children lessons and 6 adult lessons. What were her total earnings? So I've gone ahead and recopied the equation. And now what we're going to do is we're going to fill in the pieces of information that were given to us. So they told us that Cheryl gave 8 children's lessons. So that means in the place of the letter C, I'm going to stick in the number 8. And Cheryl also gave 6 adult lessons. So that means in the place of the letter A, I'm going to put in 6. Anytime you replace a letter with a number, you are going to put that number inside a bracket. So now, how do we read this? This reads as 20 multiplied by 8 plus 30 multiplied by 6 plus 125. We are going to perform all of these operations in order to get a total number of earnings. So even when solving algebraic equations, you still need to follow order of operations or BEDMAS. So before we can do any of the addition, we need to perform the multiplication. So let's start with 20 multiplied by 8, which is 160, plus, and we've got another multiplication, and we have 30 multiplied by 6, which is 180, and then we still have this plus 125 hanging out at the end. Now we can add together all 3 numbers. So 160 plus 180 plus 125 is 465. So Cheryl's total earnings are 465 what? Well, we do need to make sure that we include the appropriate units. Is this 465 days, 465 dogs? Well, we're talking about earnings, which is money, so it is going to be $465. So you can choose to put in a dollar sign right in your answer, or you can include the units when you write your final concluding statement. And that's right, anytime you solve a problem, especially an algebraic problem, you do need to include what we call a therefore statement. So in math, we have a symbol used for the word therefore. So rather than having to write out the entire word therefore, the symbol that we use is a set of 3 dots, kind of in a triangular shape. That represents the word therefore. So I'm going to say, therefore, Cheryl earns a total of $465 for the season. And just as a note, because this is a very common misunderstanding or misconception, dollar signs or the dollar sign symbol always should be in front of the number. I know we say $465, so a lot of students think that we write it as $465, but that is not correct. Okay, in English-speaking Canada, we put the dollar sign at the front end of the number. So always think to yourself, if you ever were to look at a price tag, the dollar sign is at the front of the number. So keep that in mind anytime you are solving problems that have money or monetary answers.